Welcome to the Properties of Matter Speed Bag. Here we're going to go over everything that you would need to have on your half sheet of paper to play speed bag. We use a half sheet of paper so that it can go into your science lab notebook. So if you have one of those at home, that's great. I'm going to be using this screen here. So I've drawn a rectangle to represent my sheet of paper. The first thing we're going to do for this speed bag is make 4 rectangles. Draw a line across about halfway and a line down about halfway to make 4 more or less equal rectangles. The first box is going to be for the property of mass, which is the amount of matter in an object. And we're going to start off by writing the definition in the box. Now when I write, I have to write a little larger for the stylus to be able to make my letters well. On your piece of paper, you can write normal. You should be able to fit most of these definitions in one line right on the divisions. So here I'm going to write mass. And again, my letters don't come out as well as I would like them to. Mass is the amount of matter in an object. The amount of matter in an object. Mass is measured with a balance scale, so we're going to use that to represent mass in our picture. I'm going to start off with a triangle to be the base of the balance scale. Then I'm going to draw a bar and 2 boxes. Because the balance scale is tipped, I know that one box must have more mass than the other. So we're going to label this box 100 grams, and this box will be 50 grams. The last thing I'm going to do is label the tool balance scale. So we have mass is the amount of matter in an object. It's measured with a balance scale using the unit grams, and we can tell that 100 grams is more mass than 50 grams by the way that the bar is tilted. Next, we're going to move on to volume. Volume is the amount of space an object takes up. Volume. Amount of space taken up. When you do the volume of solids, if it's a perfect geometric shape, like a sphere or a cube or a pyramid, there's actually mathematical formulas that you can use to find the volume if you know how tall they are, their circumference, or whatever measurements would be appropriate for the shape. With liquids, however, you have to use special tools like beakers or graduated cylinders. We're going to draw a graduated cylinder to represent the volume. We're going to draw one small oval on the top of the page, and then another small oval over your words. On the bottom small oval, I'm going to add half a larger oval. Kind of makes it look like a fried egg a little bit. And on the top oval, I'm going to add a little triangle. It looks a little bit like a beak. I'm going to connect the 2 smaller ovals with vertical lines. I'm going to add graduations, which are marks of measurement, and there I have a graduated cylinder. The triangle on the top represents the spout that helps us pour. I'm going to add milliliters, which is the unit that most graduated cylinders use. The milli is a prefix, so it's represented with a small m, and liter is the main measurement unit for volume in the metric system, so we represent that with a capital L. And this is a graduated cylinder, so we're going to label the picture graduated cylinder. So again, volume is the amount of space an object takes up, or a substance takes up. Graduated cylinders are often used to measure volume in the unit of milliliter. The next property that we're going to measure is temperature. Temperature That should be an E. Should be TEMEPERATU. Okay. Temperature is the amount. My E's aren't turning out correctly. Of heat energy. This is measured with a thermometer. The thermometer is going to be a very long, skinny oval. I'm going to color in the bottom to represent the liquid that helps us to read a thermometer. I'm going to add the graduations. And on one side of the thermometer, I'm going to draw a degrees circle with a capital C. And that's read degrees Celsius. On this side of the circle, on this side of the thermometer, I'm going to draw a small circle to represent degrees, and I'm going to write a capital F. And that represents degrees Fahrenheit. Make sure you're not drawing the circle too big, or it looks like you're writing awk and of. Awk, of course, is a made-up word, but we want to make sure that they look like degrees Fahrenheit and degrees Celsius. The last thing we're going to do in this square is label this a thermometer. We measure heat energy with thermometers because scientists call heat energy thermal energy, and so they have that same root word of therm. Thermometers measure thermal energy or heat energy. So temperature is the amount of heat energy in an object. It's measured with thermometers, either in degrees Celsius or degrees Fahrenheit. Our very last rectangle is going to be other physical properties. We've been focusing on physical properties that can be easily measured with certain scientific tools. Other properties can't be measured as easily and are better observed with your five senses. So these other physical properties, remember you need to write everything I have on mine so that you have it on yours. Other physical properties can be observed with your five senses. We're going to represent this with two different properties. The first is going to be two circles. We're going to color one circle in. It doesn't have to be perfect. Just needs to show that it's colored in, and it's going to represent color. The next two are going to be squares. They should be about the same size, just like the circles were. One square is going to receive 4 straight lines, and the other square is going to receive 4 crinkly lines. This is going to represent texture. Color is a physical property that is observed with our eyes, which is one of our five senses for sight. And texture is a physical property that's observed with our sense of touch. And the first square would feel smooth to the touch, while the second square would feel bumpy or rough to the touch. So you need to make sure that you have everything here. If you need to pause the video or go back and rewind to get anything that you missed, of course feel free. The next thing I'm going to do is show you what you need to have when you play the game. And I'm going to do that on my magically appearing game board that I have right below what I just did. In fact, I'm just going to play the game for you as an example. I'm going to try to draw as fast as I can while still making all of the drawings look like what they're supposed to. This is called the draw phase. And I'm going to get started on 1, 2, 3, draw. I'm going to draw my mass first. I want to go quickly, but I don't want to go so quickly that my drawings don't look proper anymore. I want to make sure I have all of my units and all of my details. thermometer can be the trickiest because when you're going quickly, it doesn't always stay quite the oval you want it to. So make sure to take 1 or 2 extra tenths of a second on your thermometer so that it turns out the way you'd like. Alright, I'm almost done. I have to finish my color circles. Again, they don't have to be perfect. 3, 4 lines and 4 crinkle wiggle lines. And I'm done. The next thing that I would need to do, because all I had to do was do the drawings and the labels, is I would explain this to my partner. The way that I would explain it is I would talk about the first box first. This is a balance scale. It measures mass, which is the amount of matter in an object, using the unit grams. Then my next box is volume. Volume is the amount of matter that an object takes up, and it's measured with a graduated cylinder using the unit of milliliters. The physical property of temperature is next. It's the amount of heat energy in an object, measured with degrees Celsius or degrees Fahrenheit on the thermometer. The next physical property is the next box is physical properties that are better observed with our 5 senses, such as color and texture. That's everything you need to know how to play the Properties of Matter speed bag. I hope you enjoyed the video and keep thinking scientifically.